the y-intercept's just going to be your constant, which in this case is 5. The next one for the inverse. So we do have a kind of an algorithm to follow for the inverse. If you have it in function notation, you swap f of x or g of x, with y, then you can swap the x and y and then solve for y. Obviously, if you are into exponential, hopefully you've already been taught something about logarithms or the properties of logarithms to understand how to convert between those, because exponential and logarithmic functions are inverses of each other. So another way we can look at this is just remembering the graphs of a function and its inverse. So this graph is going to look something like this. And remember, the inverse of the function is going to be reflected about the y equals x line. So if this point is 0, 1, it's now going to be 1, 0. If previously it had a horizontal asymptote, now this graph is going to have a vertical asymptote. And if you're familiar with this graph, you would recognize it to be a logarithmic equation. But let's go through the inverse notation. So what I'm going to do is swap the x and the y. Okay. And now again, I need to solve for y, but y is as a power. So I got to get the y off the power. So what I'm going to do then is, if I remember my rules of logarithms here, if I have log base a of a to the x, then that just equals x. And I'm not going to get in depth into the rules of logarithms, but that is one rule that you're going to want to know. So therefore, that means we need to take the log of base 6 on this right-hand side to get the y off as a power. But you just can't take the log of 6 on one side. You got to take the log of 6 on both sides. So I have log base 6 of x equals log base 6 of 6 to the y. That is now going to be log base 6 of x equals y. And now we solve for y. And again, that is going to be your inverse of your function. So you can say, y inverse equals log base 6 of